Hello again, 87. Great to see everybody on Wednesday, Synchronous Learning. We'll see you again on Friday. I'm looking forward to it. This video, I'm going to try and keep it short. It's about the activity for Friday, which I'm going to do second, and then, but it's also about the beginning of energy and water and science. It's very short and with a very short activity. So let's start with that. You'll see this presentation shared with you. So basically, grade 7s, heat's all around us, but where and how does it move and why does it matter? Well, one way the heat impacts us is as it changes the state of matter. And you've learned this in grade 5. You know that if you heat up matter and it's a liquid, then it can evaporate, or if you cool down a liquid, it can freeze, and that change happens because of the amount of space that the particles take up. But why does that happen? Well, if we go to the next one, it's about kinetic energy. Now, when we talk about the temperature of something, that has to do with the amount of kinetic energy in that matter. The more kinetic energy, the faster the particles are moving, the higher the average speed, and which results in a higher temperature. But when we talk about that kinetic energy, the average speed, and when we combine it with the thermal energy, which is the amount that the particles want to attract to one another, that's when the size and the shape of the matter changes. How does that apply? Well, the example I'm going to talk about is with train crashes and breather switches. Now, this is an example of a breather switch here. And what it is, it's a sharp cut, as you can see, a sharp cut on the track. Why would they have that? Well, the rails on a train track are treated to not expand and contract. But as thermal energy increases, we call that thermal expansion. The actual matter itself gets bigger. And that's a problem when you have something as precise as a train track, because if these rails if the thermal energy were to increase, they were to expand, well, it could derail the train. And so they make a breather switch so that it gives this track some space for the thermal expansion to happen. The question for you, grade 7s, is where in your life do you see examples of thermal expansion and contraction, which is getting smaller, and can you create a solution to fix some of these problems? For me, I think about my doors. My house, part of my house is old. It's got some older doors, and in the summer, the thermal energy increases and the doors expand and stick. Grade 8, you were talking about water. Now, this, believe it or not, is sort of connected to thermal energy. We know this water cycle, right? Water evaporates, goes into the clouds, comes down as precipitation. It can freeze. That's, of course, when the thermal energy decreases. But what we want to talk about is once it hits the ground, where does it go? Well, one place it can go is into underground aquifers. And an underground aquifer is when the loose soil and the loose rock is saturated with water. And this is where we get lots of our groundwater from, but it doesn't come out clean. So grade 8, if you go to 10.5 in the Nelson textbook, where am I here? Right here. This is how we remove water out of the water cycle to use it for our own purposes. So take it out of a lake water or an aquifer, we add chemicals to it. We add a chemical called alum. And what alum does is it gets the particles that are in the material that's in the soil to bond together. It goes through here. And the combination of the chemicals and salt is called floc. Go through here. Filtration. It goes through sand and charcoal filters, clean out all the remaining little bits that didn't get taken out back here. And then often a chemical is added like chlorine to kill the microorganisms, then it's stored and pumped to your house. That is the big scale water purification system. My question for you though, grade 8s, earthships again. If you were trying to make an off-the-grid water filtration system, you wouldn't use something this elaborate. You would use something smaller. So grade 8s, don't spend too much time on this, but I would like you to go to section 10.5, scroll down. Other treatment options, reverse osmosis or ultraviolet radiation. Which one would you recommend for your earthship? Why would you choose it? It doesn't have to be a long answer, probably just like one paragraph. Which one would you choose and why? Okay, let's move on to the next part. We talked about this a little bit, synchronous learning. You're going to have three options here. We talked about this first one, trying to predict the future. What might the future look like for us? What solutions might we need to have? And it's hard to get ourselves in that mindset. So these are provocations to help you think about them. So imagine it's 10 years from now. Where are we? We're talking about education. What's the object? It's a postcard. And what mood is it trying to evoke? Excitement. What might that look like 10 years from now? Another option. The terrain, robots. We're talking about robots. What does it look like? I don't know. The object is a statue. And what is the mood? Outrage. 10 years from now, what might a statue about robots that cause outrage look like? Next one, shopping. There was a funny joke made yesterday about toilet paper, and it's true though. We're thinking about shopping 10 years from now. A public service announcement around shopping that's supposed to make us feel dread, kind of anxiety, nervousness, but like intense, heavy nervousness. What might that look like? And then the last one, oceans, device, well-being. We're thinking of the ocean. What tool might we use or device might be created 10 years from now to make us feel a sense of well-being connected to the oceans? And what I'd like you to do, this will be shared with you. You'll each have your own copy. You can either write it in text, draw a picture, design something using Canva or another sort of software, and upload that JPEG. Please do that Thursday or Friday morning so that when we meet with Heather in Synchronous Learning, we can take a look at some of those examples and get Heather's feedback, and sort of she can tell you through her lens and through the academic lens of futurists, what does she think of your ideas? How do your ideas kind of connect with the methodology that they're using to try and predict what we might need in the future? Okay, so quick little science experiment, but the focus really should be on the creativity around these objects in the future, and I'll see you Friday morning.